Hello everyone, I'm Dr. Sumit Chauhan, and in this video we will talk about network models. In networks we have two models, one TCP/IP, the another one OSI, Open System Interconnection. In each model we have different layers, and each and every layer has its own functionalities. First network model is called internet layers. Internet model. It has 5 layers: physical, data link, network, transport, and application layer. As I said, each layer has its own functionalities and responsibilities. So these 5 layers have their own responsibilities. Now when sender sends the data, the sender computer transfers this data to layer 5, which is application layer. Application layer adds a header to it, which is called H5, of all the responsibilities that he has performed. Now L4 will receive the data as L5 data along with H5. Now L4 will add an header to it, and that's called H4, and then L3 will receive the data as L4 data plus the header of fourth layer, which is transport layer. Then again L3 will receive the data as L4 data plus the header of L4, and it will add header 3 to it, and then data link layer, which is layer 2, add header to the data as well as trailer to the data, because trailer data is used for data error and correction, and then the whole this data plus header and trailer will transfer to physical layer, and that physical layer will transfer bit by bit to the receiver, and then at the receiver side this process reverses itself in the opposite direction. Means physical layer transforms the data to data link layer transforms the data to network layer, network to transport layer, and transport layer to application layer, and receiver receives the data. The another network model is called OSI model. It has 7 layers: physical, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Physical layer is responsible for transmitting individual bits from one node to the next. Responsibilities of physical layer: that physical characteristics of interfaces and medium, and how you will gonna represent the bits, what would be the data rate, means at which speed data will gonna travel, synchronization of bits, line configuration, physical topology, and transmission mode, which is simplex, half duplex, and full duplex. Data link layer is responsible for transmitting frames from one node to the next. Major responsibilities of data link layer: framing, physical addressing, flow control, error control, and access control. At data link layer, the communication is hope to hope delivery. The responsibility is hope to hope delivery, since the data that has to be communicated should be in between two local computers, means they should both be on same local area network. Now here we have an example. A node with physical address 10 sends a frame to a node with physical address 87. Since these two nodes are connected by a link, at the data link level, this frame contains physical addresses in the header. They're the only addresses needed. Now, as I said, that at physical layer we can only connect two machines which are on the local area network, and to connect the local machines we only require physical addresses. The rest of the header contains other information needed at this level. The trailer usually contains extra bits needed for error detection and correction. Now as I said, here we have the data along with 10 and 87, which are physical addresses of the sender and receiver, and at the trailer we have the bits which are required for error detection and correction. The network layer is responsible for the delivery of packets from the original source to the final destination. Now, this is the responsibility of network layer for source to destination delivery. Responsibilities of network layer: logical addressing and routing of packets. Where data link layer is responsible for hop to hop delivery, the network layer is responsible for end to end delivery, means source to destination delivery. We want to send the data from a node with network address A and physical address 10 located on one LAN to a node with a network address P and physical address 95 located on another LAN. Because the two devices are located on different networks, we cannot use physical addresses only. The physical addresses only have local direction. What we need here are universal addresses that can pass through the LAN boundaries. The network addresses have this characteristic. Now, as I said that at data link layer we only require physical addresses, but at network layer we require logical addresses. Here A and P are logical addresses and 10 and 95 are basically physical addresses. The transport layer is responsible for delivery of a message from one process to process. Transport layer is responsible for delivery of a message from one process to another. Responsibilities of transport layer: service point addressing, means here we require port addresses, segmentation and reassembly. Since we divide the uh, data into segments at transport layer, so we require segmentation and reassembly. We require connection control, flow control and error control. Where data link layer is responsible for local delivery because it requires physical addresses, and network layer is responsible for source to destination delivery, then the transport layer is responsible to process reliable delivery. Now we have a figure, it shows an example of transport layer communication. Data coming from upper layers have port addresses J and K. J is the address of the sending process and K is the address of receiving process. Since the data is larger than the network layer can handle, the data are split into two packets, each packet retaining the port addresses J and K. Then in the network layer, network addresses A and P are added to each packet. Now this is pictorial representation of process to process delivery. So we have a data at application layer, it comes to transport layer, that is data 1 and data 2 form. Transport layer adds port numbers J and K to it. Now J is the port number of the process of the sender and K is the port number of the process at the destination end. Then it transferred to network layer where you have A and P comes into the picture. A and P are basically the logical addresses, where A is basically the logical address of sender and P is the logical address of receiver. Then it further transferred to data link layer where we have a header 2. Now in header 2 we h2, that is basically the header of layer 2. The physical addresses will add it to it. The session layer is responsible for dialog control and synchronization. The presentation layer is responsible for translation, compression and encryption. The application layer is responsible for providing services to the user. Main responsibilities are network virtual terminal, file transfer, access and management, mail services, directory services. We have the summary of the responsibilities of each and every layer of internet model. This is our second model, OSI model, Open System Interconnection. It has 7 layers. We have 2 new layers added to it, session layer and presentation layer. This is how the data will travel in OSI network model. Now we have responsibilities of physical layer, data link layer, network layer. Responsibilities of transport layer, session layer, presentation layer. Responsibility of application layer. We have discussed OSI reference model and TCP/IP reference model. TCP/IP reference model is same as an internet model. Now we're going to compare both of them. Now in OSI we have 7 layers. In TCP/IP basically we have 4 layers. We combine physical layer and data link layer to host to network, and session and presentation layers are missing in TCP/IP.
Thanks for watching.